Let's take the next question. Suppose in a self I am having 10 mathematics books and 8 English books. So from this self, if I am going to select one book randomly, what is the probability of selecting a math books? So I want a math book from this self. So in order to get the math book, first we should select the book from the same category so that I can select that required book in 10C1 ways. By when you are taking a book from the self, we can expect any book, whether it is a English or math book, so we can expect anyone. That's why totally we are having 18C1 chances. So this shows the probability of selecting the math book from the self. In the same way, suppose there are 10 switches in a room which are connected to 6 fans and 4 lights. So when we are having 6 fans and 4 lights, so these 10 switches are connected to each and every fan and light. So when we are going to switch on one particular switch, what is the probability of getting light? So that means when we are going to switch on one switch, so here we are expecting a switch which is connected to light. So here there are 4 switches which are connected to that. So obviously here we can select any one. So 4C1 by out of total 10 we can switch on any one. So 4C1 by 10C1. In the same way, suppose when I am having 3 switches, so it is connected to only one bulb. So any one of them is connected to this. So what is the probability of here getting the light when you switch on the light switch? So out of 3 we can switch on any bulb any switch, so that here we are having only one chance when we can expect the light. So 1 by total 3. Next, the probability of A speaks truth is 0.4 and the probability of B speaks truth is 0.7. So the probability of A speaks the truth is 0.4 and the probability of B speaks truth is 0.7. Now if I am asking what is the probability of both speak the truth, okay, both speak the truth. So here both should speak truth. A speaks truth, probability is 0.4 and the probability of B speaks truth is 0.7. But here I want both at the same time. So now when you consider these two events, A speaks truth and B speaks truth, both are here independent events. What do you mean by independent events? When the result of one event is not depending upon the other, or the outcome of one particular event is not affecting the outcome of other event. So here these two are independent events, and for 2 independent events we know that probability of E1 intersection E2 intersection means both at the same time is equals to probability of the first event into probability of the second event. So we know that rule for here independent event. So now we are going to apply the same rule here. When I am asking the probability of both speaking the truth is simply the probability of A speaking the truth into the probability of B speaks truth. So in this way the probability of A speaks truth is 0.4 and probability of B speak truth is 0.7. So it is equals to 0.28. So the probability of both speak the truth is 0.28. Next, suppose if the value we are asking is probability of both speak the same. Now I want the probability of both speak the same, whether it is true or false we don't mind, but they should speak the same. Now let's see what do you mean by that. Here the meaning of this is simply here they may speak truth or false. So both are possible. So simply it is nothing that the probability of both speaking truth or the probability of both speaking false. So let us see how we can calculate these values. We already calculated the probability of both speaking the truth. So it is equals to probability of A into probability of B, because speaking truth is an independent event. So both speaking truth at the same time what we are asking. So probability of A and probability of B, these two are simply independent events. So we discussed that earlier. So here you can take directly R means plus. Now probability of both speaking false means if I consider that event as A dash, so probability of A dash into probability of B dash, because these two also independent events. Now what do you mean by probability of A dash is simply when the probability of A is 0.4, the probability of A dash will become again speaking truth or speaking false. These two are mutually exclusive events, because when a person is speaking truth he cannot speak false at the same time, whether it is true or false, only one value at the same time. So here it may be true or false. So that's why these two are mutually exclusive. So when we know that for two mutually exclusive events, probability of one event is equals to 1 minus probability of other event. So in this way you can calculate the probability of A dash is equals to 1 minus 0.4, which is 0.6. Now coming to B, the probability of B speak false is equals to 1 minus probability of B speaks true. So 1 minus 0.7, which is 0.3. Now when we substitute these values here, we will get probability of A is 0.4 into 0.7. This is the first value. The second one 0.6 into 0.3. So when we calculate these values, it is equals to 0.28 plus it is equals to 0.18. So it is nothing but 0.46. So in this way here they both speak the same, whether it is true or false, in 0.46. Actually what do you mean by 0.46? 46 by 100. That means they both will speak the same 46 times out of 100. Or even in this case 0.4 is nothing but 4 times out of 10 times. So for every 10 times A can speak 4 times true. In the same way B can speak 7 times true out of 10 times. So that's why sometimes the values may be given as, instead of 0.4, 0.7, it may be given as A can speak 6 times true out of 10 times. This indicates 6 by 10 is the probability of A speaking true. So whatever the value, in whatever the way we are having, we can consider it as the probability of A. Next, suppose if the question is what is the probability of getting 53 Sundays in a normal year. So here my question is, what is the probability of getting 53 Sundays in a normal year? Now let's calculate the required value. So here we want the number of, the probability of getting 53 Sundays. Generally, when you consider a normal year, so a normal year is nothing but having 365 days. So out of 365 days, how many times we can expect Sundays generally? Now the number of weeks we are having here is exactly, suppose if you take 365 and consider the number of weeks, so a week is nothing but 7 days. So here when you calculate, exactly you will be getting 52 times of 7 means here 52 weeks, and the remainder is exactly 1. That means a normal year can be written as 52 weeks plus 1 day. In order to get 53 Sundays, that 1 day should be here Sunday. Here what we are expecting, 53 Sundays. Actually we are having every week for 52 times. Now we are expecting 53 Sundays, means definitely that extra day should be a Sunday. But when you consider a week, definitely we will be having 7 days. So here this 1 day may be a Sunday or a Monday or a Tuesday, or it may be a Wednesday, or it may be a Thursday, or it may be Friday, or it may be Saturday. So out of these 7 days we want here Sunday. So the chances or the probability what we are having, favorable 1 out of 7. So there are totally 7 chances, but we want only 1. That's why here 1 by 7 is the probability of getting 53 Sundays in a normal year. Not only 53 Sundays, whether I ask 53 Fridays or 53 Mondays, for any day of the week, when we are expecting 53 times, definitely it is equals to 1 by 7. Suppose in the same way, if my question is expecting 53 Sundays, the answer is 1 by 7. Suppose if my question is 53 Sundays or 53 Fridays. So in this case, whether it is Sunday or Friday, so I don't mind, at least I want 1 here, so that we are having here 2 chances. So Sunday and Friday 2 chances, so 2 by 7 when I am expecting 53 Sundays or 53 Fridays. If I am expecting only 1, then the answer should be 1 by 7. Now the same question, but instead of asking 53 Sundays in a normal year, now I may ask in a leap year. Now the question is, what is the probability of getting 53 Sundays in a leap year? Now a leap year is nothing but exactly 366 days. So 366 days is nothing but, as we discussed, it can be written as 52 weeks plus 2 days, because 52 weeks is nothing but 364 days plus 2 days. That means every week is repeated for 52 times. Now these 2 days may be here Sunday, Monday, or Monday, Tuesday, or it may be Tuesday, Wednesday, or it may be Wednesday, Thursday, or it may be Thursday, Friday, or it may be Friday, Saturday, and even it may be Saturday and Sunday. So in this case we are having 7 possibilities, 7 chances. So the remaining 2 days may come as Sunday, Monday, or Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday, or Saturday, Sunday. So these 2 days may be any 2 consecutive days in a week. So that we are having here these many chances. Here exactly what I am asking, I want 53 Sundays. Already I got 52 Sundays because every week of the day is repeated for 52 times. So already we had 52 Sundays, and the other value what I am here expecting is another Sunday. So to get Sunday, what is the number of chances we are having? So in this case I can expect 1 Sunday, or even here I can expect a Sunday. So that here totally I am having 2 chances out of 7. So out of 7 in 2 combinations we are getting the expected value. That's why 2 out of 7 is the probability of getting 53 Sundays in a leap year. So in leap year 2 by 7, in a normal year or non-leap year it is 1 by 7. Suppose if my question is 53 Sundays or 53 Mondays. So when I am asking 53 Sundays or 53 Mondays, now I can consider this one, I can consider this one, I can consider this one. So there are 3 chances I am having. 3 out of 7 is the probability. Sunday and Monday are 2 consecutive days, that's why you are getting only 3. Suppose if my value is 53 Sundays and 53 Fridays. Now let's see how many chances I am having. So you can consider this because I am getting Sunday. Suppose if I am asking a Friday, I can consider this, even this one, and again for Sunday. So here totally I am having 4 chances out of 7. So the probability of getting 53 Sundays or 53 Fridays is equals to 4 by 7. Suppose if I ask 53 Sundays and 53 Mondays. So here what I am asking, both at the same time. I want 53 Sundays as well as 53 Mondays. So that is happening when you are getting these 2 days as Sunday and Monday only. So when here the extra 2 days we are getting as Sunday and Monday, then only it's possible. So the only one combination is giving the required value. That's why 1 by 7. Suppose if I ask the same value 53 Sundays and 53 Mondays in a normal year, then the probability is 0. Why? You cannot get 53 Sundays and 53 Mondays at the same time, because only 1 day left in a normal year. That's why only 1 day of the week can be expected for 53 times, but not both. That's why the probability will be 0 in a normal year, whereas it is 1 by 7 in leap year. So in this way you can calculate the required value. So these are the different things we discuss, whether it is related to here coins or dice or cards, balls, numbers, or any other miscellaneous. So in this way we can find out the probability. Simply probability is nothing but taking the number of favorable chances to the total number of chances, that represents the probability, and the minimum value is always 0 and the maximum value is 1. So always we can expect the values from 0 to 1. So this is all about probability what we discuss clearly.